Hello everyone, it's Peter. Welcome you back. Today we will continue for the multi-threading and concurrency. So last time we covered some basic concepts like thread, runnable, daemon thread, and the two levels of synchronization. And we left an issue not solved, that is the thread safe issue. So last time we see this code, even we use synchronized keyword, the code is not thread safe. If we run it, so sometimes it's 100, sometimes it's 200, right? So it's not in our control. Now, how to make thread safe? We talk about the synchronization. Synchronization or use a thread safe class. Using a thread safe class doesn't guarantee that your code is thread safe. So our target is to make our code thread safe. It doesn't need to use the thread safe class. That's a different story. Now, here we introduce one way, very basic way is use wait notify or wait notify all pairs in our class. So the three methods are from the top level class object. Okay, and they have to be in the synchronized block, a synchronized block or synchronized method. For synchronized block, we will talk about later, but now currently we use synchronized method. Let's come back to this one. So I want to get x always as the latest x. I don't want to get the legacy data. I want to get the latest updated data. So here I want to add a boolean to verify it is updated. Update complete. By default, it's false. Okay. Now here I don't use setX. I have another method called synchronized. This one I don't use synchronized, just setX. SetX is to give the initial value, or I can use constructor to give initial value. I can use say increase. Increase. I just say this dot x equal to x plus 1. I increase it by 1. Void increase. So after I increase, then I can read the latest value. For example, I give the initial value like set x equal to 100, and I want to increase by 1. Okay. Now, how to write the wait and notify pairs? I start from here. I can say while not complete. If it's not complete, then I call wait. Because wait will throw the test exception called interrupted exception, so I use try catch wait. Wait has some overloaded method, like you can wait for several milliseconds or others. So I don't want to go to that part. So just you can wait or wait for some time. Okay. Then catch. Okay. So it means after you update, then this condition will be false. If this update complete is true, then this condition is false. And then I will return the latest x. So this one I can change back update complete equal to false. Because I already read the latest data, so I change it back to false. And for the increase part, I can set update complete equals to true. Okay, I already updated, and okay, maybe I move this way. Be careful. I have to move this way at the end. After I finish complete, I change this one to true. Now I start run this code again. This code, the initial value is 100. So if I read x, it should be 101. This one, okay, I don't use setx. I just say obj.increase. Okay. 101. You can run many times. It's this one. What happens? It's 101. I can print out something. Okay. Waiting for latest value. Okay, I run this one, and updated value. Okay, now let's run this. Yeah, waiting for latest value, right? Then update value, after update value, then it goes to it is delayed. Okay, something's wrong. I moved the delay part. I don't have to delay will give something bad in fact for this code. Then I remove random. Okay, let's run this. You can see the two threads, the reading is first, the increase is next. Oh, now update is true. I forgot one thing. The code is running. The code is running. So let's do this. I forgot to add notify. I need to notify. Otherwise, I got some issue, right? So you see the code is running. Okay, now let's run it again. Okay, yeah. So you always get this one. If I have some delay, okay, I can add delay back. Let's see what happens. Private static delay. Okay. Now I add random back because sometimes it's update first, sometimes it's wait first. Because if I always keep this order, it's always wait first and then update second, right? So now random dot. I want you to see the different cases so that so we know either wait first or update first, then we always get the same result. Now let's run it. Okay. There's no wait, just update the value first. Okay. The second case, update first, update, let's run it. So this is waiting. Okay. So now you can see you have two different results, two different printout. So what happens here? Because we have two threads, we don't know which goes first. For example, if this thread goes first, if reading goes first, then it will move to this method, synchronized getX, right? So then update complete is false, and then this condition is true. Then we print out waiting for latest value. So it will hold, wait. Okay. Then at this time, it will release the lock, and then the second thread will come. The second thread will come, and then it will call increase. In the increase, it will get the lock, and then to update this value and print out the updated value, and then say update complete is true, then notify. And notify will release a lock again and come back to this getX. It will get this lock, and then continue. And this update complete is false. Then update complete is true. Then condition is false. Then we jump out and then return X. Maybe I write the procedure. I can say the thread A reading, thread B updating as to the thread. The case one, A goes first to call getX. Okay, so A gets the lock of who is object is obj, right? Obj's lock. It's object level lock gets obj's lock. B has to wait. The thread B has to wait. So thread A goes first to call getX. But A finds update complete equal to false. Then a calls wait method. Now we need to explain wait method. The wait method will release current object lock and move to waiting status. So wait means I have to release the current lock, because when I call wait method, I already get a lock of the object lock, right? Object lock. And then I call wait, I will release this lock. Then next, B gets obj's lock released from A. Then B updates the value and call notify. Okay. Now currently B has the lock. B has the lock, and we'll update value go inside the increase method. Okay. B calls increase method and updates the value and call notify. Now what is notify? Notify method will also release current object lock. That's notify and notify another thread that is waiting for this lock. That's the process. Now who is waiting? Thread A is waiting, right? Thread A is waiting because A released the lock and in the waiting status. So this is waiting for the lock again. Lock back, right? Now A gets the lock again and finds and reads the latest value. Okay, that's what happens. That's the case 1. Case 2, B goes first to call increase. So B gets object lock, and A has to wait, right? Because A cannot enter because it's synchronized, right? Has to wait. Yeah. Now, then B updates the value and call notify. Now this notify will notify A, right? Because A is waiting for the lock. Then A gets the lock and call getX and return the latest value. So in this getX is simple because this getX the while loop. The while condition is false because the up complete is true. So while not true, which is false, then we'll jump out to get this value. So no matter which case happens, even the two threads are launching at the same time, no matter which case happens, and then it will always get the latest value. This is wait and notify pairs. So we run several times. Okay, there's 2 different cases. You can always find out that it always gets the latest value. That's wait and notify pairs. That's one way to get make things thread safe. Now, here is an important question for wait notify and notify pair. If we call wait without synchronized keyword or synchronized block, what happens? It will throw an exception called the illegal monitor state exception. Then we can make a test. Use the thread. New package. Thread. So new class. Let's say monitor test. Now I just write the method public void call just any method I call wait directly. without the synchronized keyword. So it's not in the synchronized block. I throw illegal. I can just say cause exception. Cause exception. Throws exception. So let me test full. Test full. So I just call wait method without a synchronized keyword outside. It means because we just mentioned about that the wait method has to get a lock first, and then it will release this lock and make the thread into the waiting status. But now it's called wait directly. So I will use assertions.assert throws. This is illegal monitor exception. Change to illegal monitor state exception. Maybe I forgot. Yeah, this is correct. Then I just run this full method. Okay? So it will. Yeah, that's correct. So monitor is a lock. Is the or more official name of the lock. Okay? So we cannot call wait method directly. Or the same thing for the notify and notify all, because all the three methods will release the lock. So it means that you have to get the lock first. But how to get the lock? You have to call a synchronized method or synchronized block to get the object lock or class level lock. Okay. Now this is one thing to prove. Now let's move ahead. The difference between wait and sleep, this is quite simple. Sleep is, we call thread sleep. Sleep is a static method. Wait is a non-static, so at the object level, and sleep is class level. And the wait has to play with the locks. We can release the lock or wait for the lock. And the sleep has nothing related to lock. Okay? So sleep after some time, like sleep 100 means that sleep 1 second, and then it will wake up automatically. But the wait has to be waiting for notify. So do you remember we run some code and the code is stuck there, it's hanging there, right? Because the wait doesn't have notify, so it will wait forever. But sleep is not. Sleep after some time it will wake up automatically. So our code already proved that. Now, next is another important API like ThreadLocal and the volatile object. Volatile is a keyword, right? I first explain what is volatile. Volatile is a keyword like transient. Transient is a keyword which means that the field cannot be serialized. But the volatile, if I say a field is volatile, means that this object can be accessed from, can be read by multiple threads, but cannot be written by multiple threads. So at one time, only one thread can update this object. But at one time, multiple threads can read this object. This is volatile. Just give a concept. It's hard to test. Now let's move to ThreadLocal. For ThreadLocal class, let's go to the API. For ThreadLocal class, let's go to the API, and I will give you an example. Okay. It has basically three methods: get, set, and the initial. Maybe there's a remove method, and with the initial, then we don't have to override the protect method initial value, and I can give the initial value with the initial. This is a lambda function. Supplier is a lambda function to initial the value. Okay. And what happens is thread local. I just give a concept. Thread local is a wrapper of shared objects. Suppose I have multiple threads want to touch, access, update shared resource. There's a multi-threading issue. So one want to read, one want to write, one want to do all the operations. They may have conflict to each other. So ThreadLocal will wrap this object and provide a shallow copy for each thread. Thread A want to get this object. I go through the ThreadLocal, I get this object, and thread B get the shell copy of this object through the ThreadLocal. They can do operations independently. They will not conflict to each other. To prove this, let's make an example. Now, go to the test, new class, ThreadLocal test, ThreadLocal test. So I can use before each setup. Before each is before any test, I do the initialization. Like ThreadLocal, instead I can use integer to make things simple. Integer, I just say local. So I can call local equals to new ThreadLocal dot. Actually, you can use you can use sorry. You can override initial value method, like what happens in this one. Okay, ThreadLocal, and you can use thread and then override the initial value method. I think I can use a new way because we learned the lambda function. Then we can make things easy. Dot with initial, then return 100. Let's see how to run this one. Return just 100. In a static way. Then it's ThreadLocal dot with initial. That's a different story. Okay, now I think I still use the traditional way. And if you want to use with initial, you need to make some research. Let's use the traditional way. Use anonymous in the class. I override protected integer initial value. Just return 100. Then I write integer. Okay. Use this local way. So I give an initial value. Now, next, let's make a test. Now I make two threads. Okay. New thread. Okay. Sorry. New thread dot start. Inside new thread, I have a runnable. The Eclipse, this part is not that smart. Okay. Now in this runnable, I first get the value, integer, x equals to local dot get this value, right? And then I use I can because it's a auto box thing, I just int, it's fine. Then x equals to x plus 10. So the value will become 110. And then I use local.set x. Okay. And then I print out x equal to local.get. So if I only run this thread, there should be no problem. The x is 10. I can maybe use assertion dot assert equals 10, 110. Then local.get int value. Okay. So this is the way I read from the local ThreadLocal, and I get a value, initial value, and then plus 10. Okay, and then I get 110. Now I have another thread. Okay. After I set x, do you think that in the local it becomes 110 or still 100? I do the same thing. Now I add 100. Okay. Then I set x back. This will become 200. It becomes 200. Now let's run it. So it's working, right? Run again. So what happens is here, the first thread update this ThreadLocal, the local's variable 100 to 110, and set it back. It means it set it back. But when this one is using get again, right, then I can use I can print out something. The value inside local is local.get. Right? So this local.get and this local.get will be different because this local is still 100, is the initial value. It won't be infected by this updated value. Let's run it. Inside the local, okay. I will add the thread the current thread the get name. I add this. I don't use this column, right? And I use the same thing. The second one. Okay. Now let's run it. Then thread 2 first, thread 1 second. So this is thread 1, this is thread 2, and then if this doesn't mean that, then let's run it again. So let's run it again. It's always like this. Okay. Always 2 first, then I can use try thread.sleep. I guarantee the first one is coming first. Okay. Catch. This is a delay. I don't have to delay so much time. Okay. Now I guarantee this one is first because I don't know which one is first, so use the delay. I make sure the first thread is finished first. It's 110. But after you set the local back to this get is back to is 110, and for the second thread it read it back is still 100. So this example makes sure that two threads from the thread local, they always get the initial value, the initial copy of the value. They won't get different values. Even the first thread already updated the value to something else, but the second thread still reads the initial value, the old value. Okay. So it means that they are totally independent. So thread 1 and thread 2, they are running independently. They won't infect each other. Okay. Now, you can after that you can after two threads are finished. So maybe you can run the main thread. You can say the first thread updated the value to 110. The second thread updated the value to 200. And now I will say the main thread, if I read from the main thread, still 100 initial value. Okay. See, this is green, right? So no matter what, there are 3 threads. Thread 1, thread 2, and that's the main thread. They all, every time you use get, starting with get, they always get the initial value 100. They won't be infect each other. because this the first one update to 110, the second one update to 100, and this one still 100. The second one update to 200, and the main is still going to 100. This is ThreadLocal. That's another important way to make thread safe. That is, use ThreadLocal to wrap the shared resource, and then for multiple threads to access this shared resource, they will go to the ThreadLocal first. They will get different shallow copies of the shared resource, and they can run the shared resources independently. They won't infect each other. That's ThreadLocal. Now, next is deadlock. Deadlock. What happens in deadlock is like thread one gets the A's lock waiting for B's lock, and the thread 2 gets B's lock and waiting for A's lock. Then this becomes a deadlock. Deadlock sometimes happens with the with the nested synchronization. Like you can use a synchronized block. Synchronized block with something object of A, and then inside object of A, you use a synchronized block of object of B, right? Then you do something like this code, do something, and another one is reversely. Another thread, that's thread 1. Thread 2, what happens is they use synchronize B and synchronize A. I just use synchronize block, or maybe also synchronize method, because a method can call another method. Like you go to the first method, get the object of A, and A method call B dot something, that is to wait for object of the lock of B. Okay, but I use a synchronous block. It's easier to understand. That in this case, the one first go to the synchronize A. If you want to enter this block, it will get A block, then enter this block, and then we will want to get the object of B. If at the same time, what happens is in thread 2 is for synchronize B, it will already get B's lock, and then it waits for A's lock. So whoever cannot go ahead, because thread 2 cannot release B's lock because it's still waiting for A's lock. But thread 1 holds A's lock, but it's waiting for B's lock. So this is called deadlock. Deadlock has lots of reasons, so it depends on your code design. So if you have bad code design with like nested thread synchronization, or you have a nested code of a synchronized method, it will result in deadlock. That's one thing. And another way is that in our code we just demonstrate that if you have wait and without notify, and it's still dead. It's wait without notify. The code is hanging there, so it's still it's also called a deadlock. And how to prevent deadlock? So then, if that really happens, you need to go through your code design. Okay, so there's no uniform way to prevent that. But whenever you use multi-threading, you should be very, very, very careful. Okay, now. The last topic, we talk about executor service, callable in the future. This is a much modern technologies. I think starting from Java 5, it created concurrent package only for these special APIs. Now, first let's talk about the callable interface. Java. The callable interface, we can compare it with runnable. Callable interface also is a functional interface. It has only one method called call, and it has a return value. It's not like run. Run doesn't have a return value, so you don't know which one when it is finished. But the callable's call method, it will return a value. If you can get this value, it means that this thread is finished. Strictly saying, callable is not a thread. It's not like a roundable. Callable will be wrapped in a thread. But the good thing for callable is it returns a value. That's very important. So for each callable, it is a generic type. Okay, so we can still use the lambda function to use callable. So who will use callable? Then we can have a future one. Okay. So here's the future. So this is executor service, and then with a future to submit a new callable, okay, and then do something else, and then you can use future.get future.get to get this value. Okay. Now I can do an example for future. Let's move here. New class. Let's executor service demo. Okay. So first, let's say executor service. Let's say service equals to executor dot new. You can say fixed report. It should have only one parameter. New fixed report. Yeah, with how many threads? For example, 5 threads. That's executor service. Okay. Now, this service dot submit. You can submit roundable or callable. Let's submit a callable. Yeah, let's use this one, future. Let's return a value. Let's return an integer value. Future equals to service dot submit. Return 100. That's the future. Okay. Now, right. So in the lambda function, you don't have to say return unless you have a method. If you do this one, okay, then you say return 100. That's fine. But if you don't have a curly brace, you just say 100 directly. That's your return value. So this is the future. So this is a callable is a thread. So it will run it, and then it may take some time. For example, if I delay, again, delay is everywhere. Private static void delay. Okay, now I can delay for half seconds. Then, so this is a separate thread. Okay. I will print out thread current thread. Okay, the name is running. So there's a separate thread is running, and then after 500 milliseconds or a half second, it will return. Now, how to get this value? So I have integer result equals to future dot get. So we know this is a separate thread. If we run a runnable, or if it's a normal process, so this future get will not get any value, right? Because it will delay for half second. But with the callable, it will get this. Now there's handles exception. So now let's throw the exception. here to make things easy. Now print out result. End of main plus result. Okay. So this is a separate thread. If the code is moving on, the future.get will get nothing. But because it's a future, future and the callable is a pair. That is, callable will call something, and the future.get will wait until the future the callable returns something, and to make sure the thread is finished. Yeah. Now this code, let's run it. We'll get the correct value. So you can see after half a second, thread 1 is running, and the end of main is 100. Right? The result is obtained. Maybe you want to have more time. Let's say before that, let's say starting. Starting. Okay. It means that this code will be running after it's finished. Then the future.get will get this value. Okay. Let's do it. That's 2 seconds, so it will wait enough longer. Starting, running, end of main, right? It means future.get will wait until this callable code is finished. So this is more popular in current industry. We don't need to write a roundable or thread those things. I just define a task, and we can schedule the task, and until this task is finished, then I get this value. And here I mentioned about executor service. This executor has lots of new things. I can show this executor. Maybe I go to the API. Executors. This is the static with static method. So it has new fixed thread pool. New fixed thread pool is that I will create like 5 threads at the same time and for lots of requests. So if you have 10 threads, so only 5 threads is running. After 1 thread is finished, it's empty, then other thread will fill in. So it can. This one is to control the concurrency. So theoretically, we can have like thousands of threads running at the same time. But actually, that in some case, I don't want that happens, because if thousands of threads are writing data to a database, it will be throttled. So I want to control the concurrency. I use a new fixed thread pool. And then there's a new single thread executor, which is only 1 thread. And then we have another called new cached, right? New cache thread pool. Thread pool means that I just have, if you have more requests, I give you new thread. But for example, you have 10 requests, I give you 10 threads. If the 11th request comes, but the previous 10 thread, at least one is finished, then I don't have to create a new thread. I use the old thread to handle the new request. But if I don't have old thread, all the old thread is running, I just catch all the old thread and add a new one. But all the new ones are finished. Maybe they are all empty. They are all cached. So that's why they are cached. So we are waiting for the new request coming in. So basically, we have a new thread pool, new fixed thread pool, and thread pool is not a fixed number. It can be increased or decreased. And a new single thread pool, a single thread executor. So this is some concurrent package. We talk about the callable, future, and the executor service, and we give an example to show what happens here. Okay. I think that's pretty much for multi-threading and concurrency. So I think in the interview, if you can answer the question about the 2 levels of synchronization, thread roundable, callable, those things, and wait notify, I think it's pretty good enough that's pretty enough for the interview part. But if you want to go very deep, dive deeper, then that's lots of work to test. Okay. That's all. Thank you.